Hey everyone, what's up? In the last video we created this getAdjacentSquare method inside our square class so that we can access another square relatively from our initial position. So we're going to use this method while we calculate or compute our legal moves for each of our sub piece types. So we're going to begin with our knight class and implement this compute legal moves method for a knight piece. So let me quickly show you this image. It shows the possible squares a knight can go. So we're going to check all those squares potentially and select the ones that we can make a move and add that those squares in a list and return that list. So let's begin by initializing our resulting list, a list of squares. We'll call that legal moves, and it's going to be an array list of squares. And ultimately we're going to return that, and we are going to do some things in between. So the first thing we need to do is create a square reference that we're going to call the target square, and the target square will change 7 times. So we're going to, for example, initialize it with this square, and we're going to change it. So we set all of those and check them one by one. So firstly, let's select one square. So let's use our newly created method, getAdjacent square. So what does that say? The field is not visible. Okay, let's go to this base class, and as you see, we forgot to make that field protected. That's because that's why we weren't able to access that earlier. So let's go to our method getAdjacentSquare. As you see, it needs 2 arguments. The first one is the horizontal offset, and the second one is the vertical offset. So for example, if I want to go to that square from my initial position, I need to give 1 horizontally positive 1, it corresponds to the right, and positive 2, which corresponds to up by 2 squares. So let's alright, so now we assigned our target square this one. What we're going to do is, as I told you, change the target square 7 times, and it will cover all the 8 squares that I can potentially make a move. The target square is, actually let me copy that, and 1, 2, 3, 4, 5, 6, 7, 8. Right, we have to now give the proper offsets so that we can cover all the possible squares. So we initially select 1, 2. So let's continue from there. Minus 1, 2, 1, minus 2, and minus 1, minus 2. So let's switch 1 and 2 here. 2, 1, So 2, 1, minus 2, 1, 2, minus 1, and finally minus 2 and minus 1. Alright, so we should cover, this should cover all the squares here. And for each target square, we need to check some conditions. So there are actually 3 things that we have to check. The first thing we need to make sure is that, for example, I selected my target square as this one. So what happens if this knight is actually on the corner of the board? So suppose that this is the corner and my knight is in that square. So there are no such square here. This is out of bounds of the chessboard. Actually, all those are out of bounds, and the only valid squares that are actually on the chessboard is these 2. So because I can be anywhere on the board, such as this corner, I firstly make sure that I'm accessing a valid square. Firstly, that's the first thing I need to check. So I'm going to actually create a private method because I don't want to write the same code over and over again. So I'm going to create a method called check square, and I'm going to check my target square as an argument. I'm going to take this in square. So inside my if statement, the first thing I'm going to check is target square is not null. So this needs to be a real object and not null. So if it's not null, I'm going to check if there are any pieces on my target square. So if there are no pieces, obviously I can make a move here. There's nothing stopping me from making a move to a valid square that is not occupied by another piece. So and also I can make a move if there's a piece with the opposite color. So if there's a white piece, I can make a move here, and in the meantime I'm capturing this white piece. But if there's a black piece here, I cannot make a move. So inside this expression, I guess, I'm going to check one of 2 things. The first thing is, as I told you, target square get piece is null. So if it's null, I can make a move. Or target square get piece side. So the side of the piece on the target square, if it's not equal to my side, I can also make a move. So if the statement inside this, if the expression inside this if statement is true, I'm basically going to add the target square to my legal moves list. So legal moves add target square. Of course, I have to take the legal moves as an argument. Alright, that's it. I'm going to call this method after each time I change my target square. So check square legal moves target paste that. So as you see, there are 8 target squares, 8 different target squares, and I'm calling this method for each of them. So just to be clear, let me go over this if statement once more. What I'm doing here is, firstly, I'm checking if this target square is actually a real square on the chessboard. So it needs to be true. And so it needs to be not null. So if that's the case, I'm checking 2 conditions. If one of them is true, at least, I can make a move. So one of those conditions is if the target square is not occupied by no piece, so it's empty, I can make a move. And if it's not empty, I can still make a move if the square on that target, if the piece on that target square is an enemy piece. So I can capture that piece and make a move. So that's it. We have completed our implementation of this compute legal moves method for our night class. So in the following videos, we're going to implement this method for our other piece types. So take care. See you in the next video.